Let us discuss how to develop stiffness matrix for sway analysis of frame. First one, I will draw the figure showing the different coordinates, that is coordinate 1 deflection, second one coordinate 2 clockwise rotation I will take, third one third coordinate, that is again rotation. So our aim is to develop stiffness matrix for sway frame. So first we have to apply unit displacement at coordinate 1 or traditional method. First applying unit displacement at 1, that is coordinate 1, that is delta is equal to deflection is equal to 1. Let us see how that diagram is going to appear. So same frame I will take, this is my frame. So I will apply one in first coordinate, that is K11, force at 1 due to unit displacement at 1. In our second coordinate, that is here, that is K21, that is force at 2 due to unit displacement at 1. At the same time I will draw one more coordinate, that is K31, that is force at 3 due to unit displacement at 1. So if I apply unit displacement here, this is going to deflect in this shape. Same way it is going to deflect like that. That is there is more. We will assume it as this is stiff beam. There is no deflection in this beam. There is no any changes in this beam. That is rigid beam. Therefore, if I consider this is unit displacement, that is delta is equal to 1. Here also same delta is going to apply. That is delta is equal to 1. So let us assume this is HA, horizontal force. At the same time this is HB, because we taken this as A, B, C and D. If this is HB, here HC, here HD. Now let's we can take this beam member AB can be written like, I will just consider this beam AB but in horizontal direction, this way. This is fixed support, so it is going to deflect like this. So to avoid that deflection, because of this deflection, here one anti-clockwise moment is going to develop, that is 6EI by L square. That is nothing but 6EI delta by L square, but this delta is nothing but 1. At the same time, here one moment is going to develop because of this deflection, that is 6 ei delta by L square, that is also delta is equal to 1. This value is not is equal to 1, that delta value is equal to 1. Therefore we have to find the support reaction. Find the reaction for this member. Find the reaction for this member. For this I will consider that whatever the reaction we consider, we taken this as HA, this is HB, okay. Then this is the moment going to develop because of that deflection, that is 6 ei. If I see that one, this is L1, L2, then L3. So total length of that beam is L1. See, that is nothing but 6 ei by L1 square. At the same time 6 ei divided by L1 square, because delta is equal to 1. So if I take sigma Fy is equal to 0, HA minus HB is equal to 0, therefore HA is equal to HB. Our aim is to find the support reaction, so I will take sigma MA is equal to 0. Therefore if I take moment about A, this is A and B. So if I take H, consider HB, that is HB into L1 going to rotate clockwise. If I consider this point, if I apply HB into L1 clockwise, if I see this moment, that is anti-clockwise, therefore minus 6 ei by L1 minus 6 ei by L1, that is equal to 0. I want to find HB value. HB is equal to minus 12, if I bring that to the other side, plus 12 ei divided by L1 into L1, that is L1 square. This is L1 square, so this will become L1 cube. If I simplify this one, therefore HB is equal to 12 ei by L1 cube. Similarly HA is equal to 12 ei divided by L1 cube, that because H1 HA is equal to HB. So if I go to next step, therefore let's see what is K11. By using this support reaction, let us consider or let us calculate what is K11. So K11 is equal to, what is K11? That is force at 1 due to unit deflection at 1. So if I see that one, that is nothing but HB plus HC. Therefore K11 is equal to HB plus HC. If I develop HC, that is 12, if I develop HC, that is 12 ei divided by, for HB 12 ei divided by L1 square, for HC similarly 12 ei divided by L3 cube, not L1 square, L1 cube. Similarly for HC 12 ei divided by L3 cube. So therefore here if I consider K11 HB plus HC, that is 12EI divided by L1Q plus 12EI divided by L3Q. Same way, next one K21. How to find K21? That is forcing 2 due to unit deflection at 1. So if I see K21, so because of this HA, our deflection is nothing but 6 EI divided by L1 square. Similarly, one more deflection here, that is this one, 6 EI divided by L1 square. Similarly here also 6 EI divided by L3 square. At the same time one more reaction here, that is rotation, 6 EI divided by L3 square. So if I see that K21, our assumption is clockwise, but our rotation acting in anti-clockwise. Therefore K21 is equal to minus 6 EI divided by L1 square. At the same time K31 is equal to K31, that is clockwise, but our reaction is minus 6 EI divided by L3 square. So we calculated first three terms, that is K11 is equal to 12 EI divided by L1Q plus 12 EI divided by L3Q. K21 is equal to minus 6 EI divided by L1 square. K31 is equal to minus 6 EI divided by L3 square. Next we have to find other three terms. So for that, applying unit displacement at coordinate 2, that is theta b is equal to 1. Let's see how to draw the figure. So I will consider same frame whatever we considered for our problem. So this frame, so our first coordinate, that is here horizontal, that is K12, that is force at 1 due to deflection at 2. Again same here, K22, moment at 2 or force at 2 due to unit displacement at 2. Last one, K32, force at 3 due to unit displacement at 2. Again I will draw the reaction. This is HA, this I will take HB, this is HC, then last one HD. So as we know, if I apply one moment at that particular or unit deflection at particular coordinate, so at that point if I see the deflection pattern, I am applying clockwise moment, it is going to deflect like this beam going to deflect in this way. If I draw the slope like this, so this unit deflection, that is theta b is equal to 1. At the same time we taken this as A, B and C. This theta b is is equal to 1. So because of that deflection, moment is going to develop, that is, as we know, 4EI on this beam L2. For first beam, moment is going to develop at where we are providing the rotation. At that point, moment is 4EI divided by L1, because length of this beam is L1, this is L2, this is L3. So wherever you are providing unit deflection, at that point moment is 4EI divided by L1. On the other point, same clockwise moment, 2EI divided by L1. So here 4EI divided by L2 on the other point or far end, again same clockwise, but half of that one, that is 2EI divided by L2. So therefore what we did here, unit rotation is given at B. So moment at the near end, that is 4EI theta divided by L, where theta is nothing but 1, therefore 4EI divided by, same thing we done here, 4EI divided by L1. In common I will take it as L or L1. So moment at the far end, 2EI theta divided by L, this is nothing but 1, therefore 2EI divided by L1. Same we applied for second beam, where near end 4EI divided by L1, far end 2EI divided by L2. So now we can write this member 2, member AB can be written as, if I take this member A and B, this is HA, HB is acting like this. So here on clockwise moment is acting, that is 2EI divided by L1. Here also on clockwise moment is acting, this is 4EI divided by L1. We know that this length is L1. I want to find the support reaction. For that, sigma Fy is equal to 0, that is HA is equal to HB, that HA minus HB, therefore HA is equal to HB. Sigma MA is equal to 0. I have to take moment about A, therefore HB, if I apply HB clockwise, HB into length is L1, HB into L1 plus 2EI divided by L1 plus 4EI divided by L1 is equal to 0. 2EI by L1 plus 4EI by L1 is equal to 0. So therefore HB is equal to minus 6EI divided by L1. I will bring that to down, that was 6EI divided by L1 square, that is HB. So we know that HA is equal to HB, therefore HA is equal to minus 6EI divided by L1 square. HA is equal to HB, but we require only HB here. Now what we have to do is we have to calculate k12 value, k22 value, k32 value. Let's see what is k12 value, that is force at 1 due to unit displacement at 1. So k12 is equal to, that is nothing but hb. What is hb? hb is equal to minus 6ei divided by l1 square, minus 6ei divided by l1 square. Now let's see what is k22. Moment at force at 2 due to unit displacement at 2, that is k22 is equal to 4ei divided by l2 plus one more moment is acting at the same point, k22. If I see that this one is also clockwise at b point, this is also clockwise about b point, therefore 4ei divided by l2, 4e plus 4ei divided by l1. I'll write it like this: k22 is equal to 4ei divided by l1 plus 4ei divided by l2. Last one we have to see k32. If I see that one, k32, only one moment is acting, therefore that value is k2ei divided by l. Therefore k32 is equal to 2ei divided by l2, 2ei divided by l2. So we found other three elements, or other three elements of stiffness matrix. We have to find last three elements. For that we have to apply one more unit displacement at coordinate 3. Let us take applying unit displacement at 3, that is coordinate 3. So let us draw that diagram. So this is my first beam, third beam. So first coordinate k13 unit displacement or unit force at 1 due to unit displacement at 3. One more k23 force at 2 due to unit displacement at 3. Last one k33 force at 3 due to unit displacement at 3. If I apply unit displacement here, this is going to rotate in this way. If I draw the slope, it will be like this. So that is nothing but theta c is equal to 1, theta c is equal to 1. So if I take the at wherever you are providing the unit displacement or unit rotation, at that point moment will be 4ei divided by l2, because this length is l2, l1, l3. At the far end again clockwise moment 2ei divided by l2. At this point moment will be 4ei divided by l3. On the far end, that is also clockwise, 2ei divided by l3. We know that whatever the derivation we did here in previous step, so just we have to convert that into our present condition. Therefore k13 is equal to, previous case it was l1, but in this case it will be l3, deflection on l3. Therefore minus 6ei divided, same one thing we have to convert for this condition, that is minus 6ei divided by L3 square. If I consider K2 K23, that is 2EI divided by L2. If I consider K33, we can see two moments, that is 4EI divided by L2 and 4EI divided by L3, that is 4EI divided by L2 plus 4EI divided by L3. Okay, now we can combine all the terms of our stiffness matrix. So we can write K is equal to, first we have to see what is K11. So K11 we calculated here, that is 12EI divided by L1 cube, 12EI divided by L1 cube plus 12EI divided by L3 cube, 12EI divided by L3 cube. Similarly, minus 6EI divided by L1 square, 6EI divided by L1 square, 6EI divided by L3 square, 6EI divided by 6EI divided by L3 square. Similarly, we calculated K12, K22, K33, that is minus 6EI divided by L1 square. As we know, this is symmetric matrix, so this term is similar to this one. Again, K22, that is 2EI, symmetric matrix, this is minus 6EI divided by L1 square, 6EI divided by L1 square. Next one, 4EI divided by L1 square plus 4EI, well, not L1 square, 4EI divided by L1 plus 4EI divided by L2, L1 plus 4EI divided by L2. Last one, 2EI divided by L2, 2EI divided by L2. So easily we can write this as this is symmetric matrix, this will be 2EI divided by L2. Similarly, I can write this one, you can observe the same value, minus 6EI divided by L3 square. Last we have to remember, that is 4EI divided by L2 plus 4EI divided by L3. Each time no need to derive the formula, so just we have to remember this stiffness matrix, so easily we can solve any problem. That is, if they given this type of problem with the horizontal load, these are the support, if they given on horizontal load, so we have to take this as coordinate 1, coordinate 2, coordinate 3, 1, that is L1, L2, L3. If I substitute these values here, L1 may be 4 meter or any value, so if I directly we can find the stiffness matrix for sway analysis of any frame using this formula.